Thank you. Should I start?
Yes, please. You can share your screen now.
Okay, great. Thank you very much for the introduction. It's a pleasure to talk to you all today. And we are excited to present our work that is it's a result of like 3 years of work, I guess. So the broad category of what we're talking about today is about the impact of extreme heat and what are the strategies that we have for like basically seeking refuge from the heat, like what are the patterns that we see by using data from smartphones. So the overview of our talk for today, it starts with talking about like the patterns of climate change. Specifically, our cases are from LA County in California. And what is the heat vulnerability in relation to these extreme heat events? Like what are the population that are being impacted by it? And an overview of how we incorporated mobility data from cell phone users and in relation to 3 elements of shade, cooling centers, and parks. So we will go through each of these together. So in general, we've been experiencing a lot more heat waves almost everywhere, and especially in California as well. Like, so this is a map of US. You see, like also in the news that like we are getting used to seeing that we are experiencing more days during heat advisories. There are certain groups in population who are more vulnerable to experience adverse effects from heat. These are including specific population because of, for example, age, elderly or younger children, the people who are in poverty, basically if they cannot afford cooling mechanisms for their homes, and or their houses are not built to adapt to differences in temperature. And also being outdoor, like outdoor workers, or if they are on house population. These are groups of population who are very much vulnerable. Also, if they have any underlying health conditions. So on the other side of where are the places who are experiencing this extreme heat, we see that the patterns are very different. This is a map of land surface temperature. Maybe not the best way to measure heat, but it shows like the diversity of experiencing different temperatures across the landscape of Los Angeles. Also in this statistics bar chart, you see that the number of fatalities from heat events has been the highest in relation to weather events, specifically in US, and also it's one of the highest across the world as well. And it's noteworthy to say that even though we are seeing this is the highest, we know that with heat events, they are very much underreported. So accounting for all those that is underreported, we can see that it is one of the highest hazard events for us. In terms of thinking about hazards, there are cycles for disaster management that if we think it starts from having an event, a hazardous event, for example, extreme heat, we have the phases of responding to it, recovering from it, and we also have the chance of mitigating and preparing before something happens. So using this big data has become a part of more recent patterns of responding to disasters and preparing for them, in addition for its uses in recovery as well. But this input of having from big data, either from our cell phones or using social media, has become an information from individuals to see what is the behavioral pattern of individuals in relation to the events and how it can inform us to better prepare for disasters or events, in this case, for extreme heat. So for this case, we are testing three mechanisms that are considered as mitigation mechanisms for dealing with the extreme heat. One of them is using shade outside, the other is using cooling centers, and the other is using parks. So we are testing to see how people are using these different heat refuges when there is a heat event. For testing that, we are using a smartphone data to see how much people's behavior changed when it was a heat event versus the days that we didn't have any heat event. For that, we picked 2 months in July and August of 2017. And this is a time before COVID, so we don't see the impact of COVID in people's choices. And also, it's 2 months that we had two major heat waves. So we picked the days that had heat events and picked the same day of the week that it didn't have a heat event to compare day by day to see how much people's behavior have changed. For these, we have about 24 million points of location data for these 2 months. So there are some challenges with that. It's a large data, so it takes some time to process all of it. And some of the combinations of the data are multivariate. For example, what time of the day, what time of the week. So these are all changes in the behavior of people in how they are using space during heat events. Also, the data that we had has different variations in how precise they are. So there are differences in horizontal and vertical accuracy. And also, they all have a speed records for them. So that's what we use to say if they are moving, if they are walking, if they are in the car, and use that to refine our data. So those also had some inaccuracies within them. So there were some additional changes that we had to make for the data. So refine the horizontal accuracy, refine the speed. So the final data set that we were using after all these refinements were a portion of this huge data set to make sure that it is being representative. So here we have our first poll question in relation to the first thing that we're going to be discussing, which is the shade-seeking behavior. So I will wait for the poll to go. Okay.
I have stopped the poll, yes.
Okay, yes, so I see 66% think they use a shaded path, 24% they stay indoors, and 10% thinking that they would do the same thing as the other days. Okay. Okay, so I can continue, sorry. Okay. So now moving on to see which one of the groups that responded were closer to what we found. So we looked at a very particular, I'm going to wait to discuss and then I will come back to answer which one was what we found also. So we picked a neighborhood you see the map of California. This is Los Angeles County, and within Los Angeles County, we picked a neighborhood. We had to pick a neighborhood that we can have this like very fine-grained data, be able to analysis for the whole LA County. That would be taking us a lot more time. So for this neighborhood, it's also a very vulnerable neighborhood to extreme heat events. They are experiencing that. looking at the composition of it, you see they do not have that much vegetation in that area. It's mostly residential, single family homes, and also you see how much heat, land surface temperature is being experienced there during heat events. And here you see the map of shade. So the way that we looked at seeing where shade is was, I should give a shout out to my colleague, Dr. J.T. Alessandro, who did this part of mapping the shade. And this was using the data from a LiDAR, which is point data, and using point clouds to kind of see what is the landscape there, and using the sun angle to see what would be the shade during different times of the day. So you will see here at the chart, looking at different also land use, what would be the shade during different times of the day. So we have shade at 4:30, 3:30, 2:30, and 1:30 for residential, low and high density, commercial, industrial, institutional, and open space land uses. We see a lot more shade during in places that are residential and also commercial more. So availability of the shade also changes by the time of the day also. So we included all of this in addition to seeing where are the people that are pedestrians. So we took out anyone that was not in a car or moving faster than a certain speed that we define as a speed of walking. So these are the people who are walking in the neighborhood, and we looked at them day by day and also looked at them in the days that are heat event and not heat event. So that comparison. The left one is for weekend, the right one on the weekdays, because people's behaviors change if it's weekend or weekday. And we see that there are areas that people are being concentrated more during these, but there wasn't like a major pattern to see if they are seeking any place. Other than we see a lot more concentration around bus stops or commercial areas. But now looking at how much this intersection of where we have the shade and where are people being concentrated the most, we actually saw that, so I will go into talk about the chart, but we actually saw that people do not change their behavior that much. So they would go and do whatever they have to do, basically. You see on the left on the weekday and on the right on the weekend, the top charts are for the residents who are from that neighborhood, and the bottom one are non-residents. So the way that we picked who are the residents are the cell phone users who are staying in that neighborhood within building boundaries during nighttime. So that's how we define who are the residents. So if they are not staying in that neighborhood during nighttime, we assumed that they are non-residents. So in particular, we saw that residents would be using shade more during weekdays, but in the weekends, the changes are not that different. So these right ones are shade, left ones are no shade, and also red is heat event, blue is control day. So you see that on heat events and in shade, there is a little bit of more use of the shaded area, but maybe not during the weekend. So in general, we saw the pattern that during the weekend, people are staying more indoor probably. So not using that much of the outside space. Particularly, it could be related that they have more agency. They are more able to decide if they want to stay indoors instead of going out. And if they are going out, doing the statistics, we saw that there isn't that much of a huge difference, significant difference, if they are using shade or not using shade. So we saw that basically people do what they have to do. So doing that poll, you kind of see now how your guesses would align with what we found for this neighborhood. I should mention this is a specific neighborhood. It has more single family, and doing this for other neighborhoods, we might also see maybe some other patterns as well. Okay, so now I'm going to move to our next poll question for cooling centers. And giving the podium to Travis.
Thank you. So your question here, just so you, formal and informal cooling centers are exactly what you might imagine. Formal being one that's designated by some agency, jurisdiction, etc. Informal being a place that is cool, is air-conditioned space like a mall, shopping center, things like that that are open to the public, but aren't designated as cooling centers. All right, so we've closed the poll here. So 45% of you think that formal and informal cooling centers are visited similarly, that there's no difference between it being designated as a center or not. 29% with formal centers visited more than informal centers, and 26 saying that cooling centers are visited during extreme heat days, just like non-heat events. Basically, that neither of them are doing a whole lot. Great feedback there. So we'll move on to the next slide and talk a little bit about this chapter of the work on cooling centers. So cooling centers, of course, are intended to mitigate the harmful events of extreme heat events by giving people respite from elevated body temperatures, extreme sunlight exposure, and all of those things. But we have relatively little data about how effective they are in terms of their use. And mobile phone data gave us an opportunity to get much higher numbers on their use than other approaches, which would be surveys of individuals, very intensive effort to get relatively fewer data points. So we're looking at the use of smartphones in their informal and informal centers. And I just want to say a little bit about the smartphone data here. One is that these data are all from people who opted in to allow their locations to be shared by agreeing to the terms and conditions of an app. The data are obtained through a third-party provider with ethical limitations built into the data agreement in terms of how you use them. So we can, for example, track an individual phone by an advertiser ID, but we have no information about who the person is. But then you can track it and figure out where it goes. But you're precluded legally from depicting that in any map or sharing any specific location. In fact, of sharing any location that has less than, I think it's 20 phones in an area, you're not actually supposed to do that under the terms of the agreement. So this is already built into the case of obtaining these kinds of data from a data broker. But the trade-off of that, of course, is that we can gain insights that are almost impossible to gain in other ways. So here we're looking at formal versus informal centers, formal being parks, libraries, senior centers, anything that's designated. It may have another day job, as it were, but gets designated as a cooling center during an extreme heat event and advertised as such, whereas informal ones are shopping centers, rec centers, pools, etc., that we surmise that people are using to cool down, but in fact aren't designated as formal cooling centers. So we'll go to the next slide here. There's a lot of effort that goes into cleaning the data, accessing it. Of course, it falls under the category of big data. You can't load it all at once into a GIS or anything like that. You've got to query it by code bit by bit. And then there's a lot of standardization that has to go on because it is an opportunistic data set. And so the number of what we refer to as a ping is a device at a location at a time. So it's latitude, longitude, error, speed, and an advertiser ID at a particular time. And so we have to standardize then by how many pings we have in an hour and then extrapolate upward from there as if to figure out how this might reflect in terms of the entire population. It is between 1 and 1.5% of all of the mobile phones in the county of Los Angeles during the time period. So it's a significant percentage of that total if you think about the extrapolations we make from public opinion polling, for example. So to measure the use, we take the pings in each center type, we divide by the area, that's the area of the building footprint, and then we standardize for differences in pings per hour, and then we extrapolate out so that we're not dealing with numbers that are minuscule in terms of the tiny numbers, that we get something that's more like a realistic for numbers of people. And then we looked at, if we go to the next slide, for cooling centers, occupancy, formal centers versus informal centers, extreme heat days versus baseline days, the vulnerability. So that would be the social vulnerability using social vulnerability index, SOVI, of the user location. That's tracking the phone back to where its resting location at night between 1 and 4 a.m. or 2 and 5, I forget. It depends on daylight saving time. And the center location, the vulnerability of the community in which the community center is. And then we also looked a little bit at the transportation issues. So if you go to the next slide, that would be the distance between the cooling center and a bus stop or a train stop, distance to a transit location, and also the raw distance from the cooling center to the users, to try to get some idea about how distance is influencing cooling center use. So if we go to the next slide, then the left-hand side and upper statement there has to do with the vulnerability of them. So the dots there are actual cooling centers that are divided into, when you divide a quantile into 3 triciles, that's not, it's a quantile, 3 quantiles. And so the high, medium, and low, and then the demographic blocks there are divided as well. And what we find is that, and this is no surprise, but it's confirmed something that people advocate for a lot, is that the cooling centers that are in high vulnerability areas serve more high vulnerability people. And that just sort of makes perfect sense from a geographic perspective, but it's good to confirm that and show and leading to the guidance perhaps that if you want to serve high vulnerability populations, yes, indeed, you need to put cooling centers in high vulnerability areas. Second, and the other thing is you will not see, for reasons of privacy, any one mobile phone location on any map, and that is intentional. It'd be fun to share all that, but you can't do it. So the second thing that we see in these data is that on extreme heat days, looking through the afternoon, and here we focused our study on the hotter part of the day, second half of the day, that there are more people staying in the centers longer into the afternoon. And this goes for formal and informal centers. So the red bars on the right-hand side being higher than the gray bars being the control days, red bars being the extreme heat days. As we go 12, 1, 2, 3, we see that there's the numbers don't fall off like they do during a normal day. In extreme heat days, you get fewer. So this is the idea that people are actually going to these places and then sticking around for a while, perhaps going through the logic of, no, I don't want to go back outside or back home to my unair conditioned apartment, for example. So if we go to the next slide, then this is summarizing visits by these different categories by heat and control days. And I'll just walk through this and this is published now and it's open access. You can download the paper if you'd like. Some of you may have already. So we have formal, the top of the chart is the formal cooling centers and then informal cooling centers, the different categories of them. And then because we're from the United States, acres of the area, that's the actual footprint of the buildings, and then people per acre on control versus heat days. And so there you want to look at the fact that the one place where we see a rather significant increase in the number of people per acre inside these buildings is at formal county centers. It goes from 9.9 to 12.94 between control days and extreme heat days. Shopping centers, there's a lot more of them, a lot larger area. It goes up modestly, like from 9 to 9.3. And some other things like rec centers and pools actually go down. Actually, rec centers go down a little bit, pools go up a little bit. But the big one here that was of interest is that the county cooling centers do show this marked increase, but those numbers are quite small relative to the total area that is represented by shopping centers. So more people in absolute terms are going to shopping centers. And if we go to the last two columns, staying there longer. So this is just a duration ratio that allows us to understand how long people are staying in a location. And what we find is that across the board during extreme heat days, the same I say people, they're not actually people, they're devices. The same devices are staying in these locations longer periods during extreme heat days than they are during the control days. And that is across every single type there of these air-conditioned spaces. So if we go to the next slide, this takes us into the distance questions. And what we find is that there is a distance decay function, as you would expect, so that the farther away a person is from a cooling center, the less likely they're to go to it. What's really interesting here, though, is that the explanatory power of that is much greater for formal centers than it is for informal centers. And so what this means is that people will travel longer distances to go to the things that are in the informal category, like a shopping center that's air conditioned, compared to going to a formal cooling center that might be a library, for example, or a senior center that has opened its doors to people to have respite from the heat during extreme heat day. So the formal centers, if we remember, they're the ones that see the greater use. They're also, the use of them is much more predicted by proximity, which leads us back to the same conclusion as before, that if you want to serve people that are vulnerable, especially by formal centers, you need to be putting them in close proximity to those people. We also find, and I'm not going to show you the result here, but distance to the nearest transit stop influences use as well. And the closer a formal or informal center is to a transit stop, the higher use it gets during extreme heat events. There's some odd additional results, again, that I'm not going to show you, but that suggest that if it's close to people but far enough away that they have to walk, that gets used less during extreme heat events. So people are, there's some evidence in the data that people are actually avoiding walking during extreme heat events, which makes complete sense. So if you go to the next slide, Sahar and I did not do this all on our own. This particular part on cooling centers was done as part of the senior practicum in environmental science at UCLA with this team of seniors who graduated a year and a half ago now, and produced a entire story map that you can go and investigate on that. There'll be a link that comes up in a second. And then we took the project where we had coached them through and reworked it into the paper that came out in Applied Geography on smart location and cooling centers. So they're all headed off to their careers and grad school with having done this, what I think is actually quite an interesting piece of work. And the next section is about the effectiveness of parks and another senior practicum project for the next year with the question that we'll turn to you now for the poll. Are there changes in park visits during heat waves? Do you think that parks are visited more? Do you think they're visited less? Or do you think that there's no difference whatsoever? We're almost there. Go ahead and get your answers in. Wonderful. Okay, so as you'll see here, was it plurality? Believe that parks are visited less during heat waves, followed by more. So 35% of you are going to go with more, and 15% go with no change. So same approach, same data set, same heat waves, same months. If we go to the next slide, this is the first on the left is by day of the week. Percentage of visitors to parks on those days, control versus extreme heat. Control are blue, extreme heat is red. And those of you who had parks are used less during extreme heat days, you win, except for Friday. But I think we're willing to say that, yeah, there's people are going to not be out as much overall during extreme heat. Other interesting thing, we looked at the hour of the day. So here we have on the right-hand side, that's noon to 7 p.m. and its visitors. The bottom lines are the weekday. So yes, fewer people go to parks on weekdays, but they increase as people get out of work. So the 5 o'clock hour is greater and the 6 o'clock hour is greater. So that's a very clear signal of it. And that extreme heat days, that's just uniformly, there's fewer. On the weekend, more people at parks, the usage peaks in around 3 o'clock. And maybe there's a hint there in the data that on an extreme heat day, on the weekend, people stay out in parks longer. If you look at that 7 p.m. line, the dotted weekend heat day is higher than the weekend control day. Not sure if we're going to read too much into that, but it's possible. But again, across the board, less use between the two. We also looked at this spatially. And so these are, if you go to the next slide, two examples of a Saturday and a Monday. Now, red means it's used more during an extreme heat day, and blue means it's using less during extreme heat day. And there's clearly a difference between weekdays and weekends. This Saturday, what you see lit up is the entire sandy beach coast of Los Angeles County. So that is, for those of you who aren't familiar with Los Angeles, that's Santa Monica, Venice Beach, the South Bay beaches, Hermosa, Manhattan, Redondo, etc. And then the farthest one down is Long Beach. So very clearly, people in Los Angeles County during extreme heat day go to the beach. Now, on the weekend, for the weekday there, it's a little all over the place. So no clear pattern there. That's fine. We can go to the next slide. So the next slide talks about the different types of parks and how their usage changes. And so on the left-hand side, this is extreme heat versus non-extreme heat on weekend versus weekday. And the big thing we see here is that on extreme heat days, city parks serve fewer park visitors on the weekend, and city parks tend to be smaller neighborhood parks versus state and county parks, which tend to be larger regional parks. So city parks on extreme heat days are serving fewer visitors on the weekend, but a little bit more on weekdays. And state parks are the opposite. They're serving more visitors on the extreme heat days during weekends and fewer on weekdays. And this seems to be like that if someone's going to go to a park during extreme heat day, they're not going to go to their neighborhood park. They're going to go to a regional park that may, in our instance here in Los Angeles, is probably more likely to have a water feature or something, bigger open spaces that may feel different in an extreme heat situation, bigger, larger open spaces. And so for city parks, the percentage of visitors dropped on the weekend regardless of temperature. State parks had the opposite. And so there's some interesting patterns here that could be of use to how park managers sort of plan for programming around extreme heat and the ways. And we also looked at some amenities. I'm not going to show those results, like does having a splash pad in a park influence the use during extreme heat? And we found no statistically significant signal there. So if we go to the next slide, we then also, similar to the cooling centers, looked at the social sensitivity index. This is a County of LA index for vulnerability, and the vulnerability of the park, so where the park is located, what census tract it is in, versus the vulnerability of the user. Again, doing the aggregating the kind of creepy activity of going back and seeing where people's devices are at night and assigning some demographic characteristics to them based on that. And what we see here, well, there's a couple of things. First, one on the left, that's the lowest sensitivity. So these are going to the wealthier, more, less vulnerable communities. Those lines are all greater, which means people use parks in low vulnerability areas more than they do in high vulnerability areas. They also, because we're tracking both the people and the park, or the device and the park, that there's, if you're from a low vulnerability area, you're much more likely to use a low vulnerability park. Again, that's the distance feature that we saw before. Geography matters. So that would be the light blue line in the upper left versus the dark red line in the lower right. So the dark red bar in the lower right, extreme heat from extreme, people from high vulnerability areas using high vulnerability parks versus people from, or the light red bar, people from low vulnerability areas using low vulnerability parks. The other thing that you see here that I find interesting is that the number of people from high vulnerability areas that are using parks in low vulnerability areas is considerably greater than the inverse, which means people are going and finding parks in low vulnerability areas, which tend to have better amenities, as a means of sort of curating their experience of the landscape to avoid, maybe nearby parks that have various reasons for them not to be attractive to them. This gets beyond the extreme heat question and just sort of into the sociology of park use. So that's another interesting thing that came out of this. And it related to that, we went ahead and, if you go to the next slide, looked at tree cover in these parks to see if this could explain their use. And so this is a scatter plot of the log of the park size and the log of the tree canopy size, and this is from a high resolution remotely sensed data set scatter plot, and by the social vulnerability of the park. So the gray dots are the most vulnerable areas. And then we just fit a regression line through it. And remember, this is a log scale. So these differences are bigger than they appear. But for high vulnerability parks, there's a little less increase per acre of park of tree canopy, meaning if you're in a vulnerable area, a bigger park is likely to have lower canopy than the same size park in a low vulnerability area. And so now we didn't go into what all that means, but it is potentially, it's going to be related to this phenomenon that's been shown now for a couple of decades of lower quality amenities in high vulnerability areas, and that we're maybe seeing that signal here too in park usage generally, even if we're not necessarily seeing it so much on extreme heat days versus non-extreme. If you go to the next slide, though, you can sort of see an example of some of what we're talking about for some of these parks, the level of tree cover, playgrounds, et cetera. And you can judge for yourself whether or not this is a place where you would go to seek shade during an extreme heat day, or whether you would go to a cooling center that has a roof and air conditioning. So with that, we intend to take this further in exploring the phenomenon here in Los Angeles, but also, if you go to the next slide, we think that this is a method that could be used in other regions. There are certainly insights to be, questions to be asked regarding it, and we're hopefully getting this adopted into vulnerability assessments and mitigation planning. Sahar and I are now on the advisory panel for the local hazard mitigation plan for the city of Los Angeles, and bringing some of these themes like to them, like if you want to give people shade, you got to give it to them where they need it. Like the shade has to be at the bus stop, not down the road. If you want to serve these communities that are most vulnerable, you absolutely have to invest in them in the community itself, not remotely, and that transit matters and distance matters, and some of these things that, again, many of them may be common sense, but it is always nice to have some quantifiable information to back it up, so that we're not just waving our hands, but are basing it on actual data about actual devices that, of course, we assume are connected to real people. So with that, thank you so much, and we'd love to take questions from you all.